Welcome to Cloud 101, presented by 7-Speed Solutions. In this episode, we'll be deciphering cloud terminology and concepts. The cloud's been around for some time, and we hear more and more about it, so maybe you just want to get up to speed. Maybe you want to just make sure that you understand all of the core concepts and terminology, some of the buzzwords that are used to really get an understanding of cloud. What you can expect from this episode. Well, first we'll consider what cloud is, just a basic definition. Then we'll look at the smartphone, the role that smartphones played in cloud. We'll look at who sells cloud. If you want to buy it, where can you go? And then the meat of this episode, some of the terminology. IaaS versus PaaS versus SaaS. You may have heard those terms before, or at least seen those acronyms. Public, private, and hybrid cloud. Subscription and consumption licensing. Single-tenant versus multi-tenant. And then scalability. Certainly you've heard scaling up, scaling down, scaling in, scaling out. We'll consider those. One thing we will not get into in this episode is the business driver for cloud. The purpose of this video is just to educate on the basic cloud concepts and terminology, not to get into business reasons for cloud. That'll be considered in a different episode. So what is cloud? Well, you might even say cloud is a buzzword. It's been used quite a bit. You've heard it maybe on the news, different articles, certainly online. In its simplest form, cloud computing means storing and accessing data and programs over, typically when we think of cloud, the internet, instead of a local computer. As we go through this episode, you'll get a better understanding of what cloud is and what it can refer to. Do you remember when the first iPhone was released? It was back in June 2007. How about the first iPad? Well, that was August 2010. Now, both weren't too long ago, if you think about it. But how many of us sitting here watching this episode have a smartphone? I would reckon probably the majority, if not everyone. How about a tablet? Again, probably everyone has a tablet or has access to a tablet. It's hard to argue that the iPhone and iPad revolutionized the smartphone and tablet industries respectively. But one of the most important things these devices brought was constant connectivity. Prior to smartphones, people carried around hotspots. I had a PCMCIA hotspot, then an Express Card hotspot, a separate device to connect to the internet. But within just the last several years, smartphones have allowed individuals to get access to the internet, really wherever you are. I gave a presentation a few years ago to an audience of a few hundred individuals, and I asked them, I said, how many of us sitting here have at least one internet-connected device on you? A device that could, even if power and Wi-Fi was lost, could still get online. Naturally, everyone in the audience raised their hand. Then I asked, how many of us have two internet-connected devices on you? At least 150 hands stayed up. I kept going, 3, 4. There was one individual that had 6 devices on him. He had a work phone, a personal phone, a hotspot, a laptop, a tablet, and so forth. Now, that may be an extreme example, but it shows that all of us have at least one internet-connected device on us at any given time, in this day and age that we live. And that's good, because the Achilles heel of cloud is connectivity. We could have, and we do have, millions and millions of servers at our disposal. With the click of a button, we can provision them, turn them on, provision applications, but without connectivity, cloud is useless. But the smartphone changed that. If we lose connectivity at an office, we set up our phone as a hotspot. We go to a Starbucks. We can find Wi-Fi anywhere and connect to cloud. So the smartphone is directly responsible for the proliferation of cloud. So with that, let's get into some of the players in the marketplace. As you can see in this picture, there are dozens, probably even hundreds, you could say, of cloud providers. Now, the largest by far at this point are Microsoft and Amazon. Those two are the largest, and then behind them there are some additional players in the industry, ones like Google and so forth. Now, we have conversations with many people that use many different cloud platforms. Really, the purpose of this slide is just to show that cloud is not defined or monopolized by one or two companies. There are and there have been many cloud providers for many years. How about this? These three acronyms, each of them 4 letters long, pronounced IaaS, PaaS, and SaaS. Now, respectively, they stand for Infrastructure as a Service, Platform as a Service, and Software as a Service. IaaS means a virtualized environment is delivered as a service by the cloud provider. This could include network, server, storage, and so forth. Platform as a Service, the computing platform, the OS, and associated services are delivered as a service by the provider. And then finally, SaaS, or Software as a Service. In this case, the applications are delivered over the internet by the provider. This was previously called an application service provider. Well, let's illustrate it a little bit. If you look in the far left, note the traditional IT. This includes everything. In the traditional, typically on-premise or in a data center IT, you start at the bottom left, the networking, storage, and servers. Those are the 3 physical components: network, storage, and server. The physical, tangible items that you can touch. Traditional IT also includes and included virtualization, the operating system, any middleware, runtime, data, and applications. So then if you look at the IaaS, or Infrastructure as a Service, you'll notice, and don't pay any attention to the red highlight just yet, but notice in the Infrastructure as a Service, the bottom 4, networking, storage, servers, and virtualization, are grayed out. That means in Infrastructure as a Service on a public cloud provider, the cloud provider is responsible for those 4 items. They still exist. The Infrastructure as a Service is still running on a physical machine somewhere in a data center, but the provider is responsible for the maintenance, the patching, the upkeep of those 4 components. Moving over one more block to the Platform as a Service, the 3rd column, if you will, you'll notice that not only are networking, storage, servers, and virtualization the responsibility of the provider, but also the operating system, middleware, and runtime. Now, the data and application side, that's not highlighted, that's still a responsibility of the end user, the client. And then finally, we go to the far right, the Software as a Service. You'll notice everything in the Software as a Service is completely grayed out, meaning the provider is responsible for every aspect of that software. Well, let's make it a little easier to understand. If you look at the IaaS, or Infrastructure as a Service, the 2nd column, you can think of those as virtual machines. Many of us are familiar with virtual machines. You still have access to log into the desktop, or in a Linux box, get into the console. You can still access them, install whatever you want. You still have the responsibility of handling everything north, if you will, of the virtualization. So operating system, any data, any applications that are installed. Going to the Platform as a Service, this would be more for something like .NET components or DevOps type usage. They still have access as a client to all the data and applications, but everything below the data, the runtime, middleware, OS, virtualization, and hardware, they really don't have any access to, and that's not that they would even want to. The idea is the provider is responsible for those. And finally, SaaS, or Software as a Service, you may start thinking, well, in what application would this be used? But really, anytime you've ever logged into Gmail, logged into your banking website, logged into a credit card, paid your mortgage online, anytime you've ever gone and logged into something online, Facebook, YouTube, that is a Software as a Service. You don't know or care, if you will, about the data, applications, runtime. You just worry that you can log in. Now, on top of all of these, traditional IT, Infrastructure as a Service, Platform as a Service, and Software as a Service, there's kind of a hidden layer, or 2 layers actually. One would be access and the other security. So even if, for instance, the Software as a Service, let's say that is Salesforce, CRM, AX Online, SharePoint Online, Office 365, you're not responsible for any of the application, data, runtime, and so forth, but as an administrator, you would still have access to grant permissions to users. And that's where that layer of access and security comes in. But everything beyond that, you don't really have any need or really desire to do anything with. The provider handles it. It's important to emphasize this is just a model. If anyone's familiar with the OSI model, it's supposed to be used to help visualize a concept. It's not to be analyzed or dissected. The purpose of this image here is just to really get an idea of that conceptual layer of infrastructure, platform, and software. Now you'll notice the bottom three are highlighted in red. Networking, servers, and storage. That's because scalability happens at the bottom three layers. When you hear someone say, we're going to scale out, scale up, we'll hear about that later. Scalability takes place at these bottom three layers. Keep that in mind. So we're going to illustrate what we just learned about. And again, it's important to recognize it's just a concept, but let's kind of put to each of these 9 layers, let's just visualize what they mean, what they entail. So first, now let's just say the application, for instance, is Google. That may not be the best example. You could say that application is anything. Maybe it's your Facebook page, or something like a SharePoint site, or something online where you have the ability to grant access to other users. Maybe it's Salesforce or CRM or something like that. But that application itself, in this case, would be Google. Now the data, and again, this is just for conceptual purposes, this is not actually what Google runs on, obviously, but the data, we would say, would be the actual virtual logical data, not the physical data that it's stored on, not the disks or spindles on hard drives, but the virtual data. In this case, we'll say something like SQL Server. The runtime. In this case, we'd say maybe it's running on a .NET application. Middleware, those would be drivers, things like TCP, IP. Sometimes there's a convolution between middleware and runtime. Technically, middleware is anything between the application and the operating system or the kernel. OS, we'll say, would be maybe Windows Server 2012. And this is the operating system that the application itself is running on, not the local operating system of the client. Virtualization, in this case, we'd say they're running Windows Hyper-V to virtualize. This is where we get to the physical, tangible items. Remember the bottom three, the things that can scale. Servers, we'll say in this case it's running, as you can see in this image, on an HP BL460 blade. Now this is, again, where the hardware starts. This is the compute layer, processors, memory. Storage, not to be, again, confused with data, this is the physical storage, where physical drives are segmented into blocks and so forth. And finally, networking. Physical networking. In this case, you can see there's an HP switch. It's what ties the compute and storage together and ties everything else above to the client. So hopefully this gives you an idea just how to visualize the difference, or the different layers, and what they each represent. Let's compare some of the offerings. So infrastructure as a service and platform as a service. There are many ways that they overlap, things that can be done on either platform. For instance, in the infrastructure as a service, or IaaS, there may be a SQL server, a database server that's running on Windows 2016, and everything's set up there. The platform example or comparable offering would be, and again, this is just an example, Azure SQL. It's still a SQL database, but you don't worry about the hardware. If you look into Azure SQL, it's still a full database engine, and in the back end, it's running on Microsoft SQL Server, but you don't have access to all of the back-end tables and stored procedures and so forth. Another infrastructure as a service offering might be Windows Remote Desktop Services, or RDS, physically installing an RDS role on a server. The platform offering would be Citrix XenApp Express, where you don't have access to configure all of the back-end details, but it's the same service that's offered to the client. Microsoft.NET, maybe you install .NET on a Windows machine. The Azure App Service would be the equivalent on the platform side. And then going back to networking, on the infrastructure as a service, any network or server admin at some point is likely configured network load balancing. The equivalent on the platform as a service end would be For instance, Azure Load Balancer. Same concept, it's just instead of being responsible for the Windows machine, installing the role, and so forth, it's just a service. You provision a load balancer in Azure, everything else behind the scenes is done for you. So that concludes the infrastructure versus platform versus software as a service. Let's look at now cloud, public, private, and hybrid. Certainly you've heard these terms being used, but we can illustrate it simply. So a private cloud is single tenant. You have control over your own hardware. Now that private cloud, if you look in the picture on the left side, can be a private cloud data center, something like Stratosphere, Fibertown, CyrusOne, where you have the ability to physically go there and touch the machines. You can put your own machines in place and so forth. Or if you look in the fourth image at the bottom, it could be an on-premise solution. It could be your own data center. You could say your own data center, whether it's sitting in a closet somewhere or in a rack in the corner of a server room, that is your private cloud. Then we look on the far right of the picture at the public cloud. Multi-tenant, large, typically multiple shared hardware or systems. I've got the large players referenced here. So there's some large players, Amazon, Google, VMware at the very top, and Microsoft. But there's also a use case for a hybrid cloud. For instance, perhaps an organization that's invested significant capital within the last 18 months into equipment. Maybe an organization that has high transaction requirements. Maybe one that wants to leverage the scale of cloud but migrate only certain applications to the cloud. Or maybe an organization that just wants to take a gradual approach. Instead of migrating everything to cloud, they want to just extend their private cloud or their on-premise cloud to a public cloud provider. That's where hybrid cloud comes in. And to be honest, most individuals, most companies are using some form of a hybrid cloud. The only ones that are strictly public basically have no systems that don't reside in the public cloud. There's no domain controller, there's no server, no service anywhere outside of the cloud. Now there's a lot in this image, but it just visualizes some of the different terminology. If you look at the top kind of blue cloud, that's public cloud. Amazon, Azure, VMware, their cloud. On the bottom left, we have a colocation or a data center. That would be Fibertown, CyrusOne, Stratosphere. And then the bottom right, in the green, we have a company's physical location, their on-premise environment. If you notice in that on-premise environment, at the very bottom, there are some company-owned pieces of equipment. That would be considered a private cloud. A private cloud can be any number of machines. A single server, if you will, could technically be considered a private cloud. It could also be said that that company-owned equipment running on-premise is considered an on-premise piece of equipment. Now go to the colocation and data center. Even though it's not running, this equipment here at the bottom is not running in the company's own physical space, because it is a leased space and it's their equipment, company-owned, that's also considered their private cloud. Again, it's not running at their location, but it is running in a data center that they have some ability and control over. You could also say that any company-owned equipment running at a data center is technically considered on-premise. But now look at the cloud side. So in this case here, we've got public cloud that it reaches into the on-premise component. This would be considered a hybrid cloud. There's company-owned equipment on-premise, but there's company-leased equipment, compute equipment in the public cloud. This is a perfect example of a hybrid cloud. We also have company-leased compute space. This is just a typical provisioned virtual machine or platform offering. This is considered public cloud. Now over here, we do have something a little more unusual. Typically, this is not the case when someone refers to private cloud, but it is possible, technically, to have a private cloud running in a public cloud environment. The difference is when something's a private cloud, it's dedicated compute. In this case, a larger company, maybe one of the Fortune 100s, might have dedicated compute resources running in a public cloud, in Amazon, Microsoft, and so forth. But again, this hopefully just illustrates the difference between public cloud, private cloud, and hybrid cloud. How about licensing? I'm sure you've heard subscription licensing, consumption licensing, and so forth. Licensing in cloud is typically broken down into two components, two separate price lists even. Um, we shouldn't confuse subscription versus perpetual licensing of software. For instance, some Dynamics ERP software has two different licensing types, subscription-based and perpetual-based. In this example, we're referring strictly to the cloud subscription and cloud consumption licensing. We can illustrate it this way. Perpetual licensing, you have the right to use as much as you want. And perpetual for software, you own it. You can run that licensing on-premise, in the cloud, whatever else. Subscription licensing for software typically means you're paying for it on a monthly basis. You only have access to that software for the extent that you continue paying the term. So for cloud, subscription, if you notice here, that's basically whether you use it or not. It's a fixed rate. It's typically something like per individual or per virtual machine and so forth. An example of subscription-based licensing would be Office 365. If you provision an Office 365 license, you're paying for that license. Whether the user logs in and uses it or not, you're paying for that license. You've purchased it, you've assigned it. It's fixed rate. Then there's consumption. Now with cloud, when someone refers to cloud, typically this is what they're referring to. Now, in this case, you pay for what's used. There's a variable scale. You can scale up, scale down. A good example of this might be an Azure IaaS, or infrastructure as a service, virtual machine, a server. If you shut that machine down, you're likely not paying, or not paying very much, but when you start it up, then you do pay for it. So that's the difference between subscription and consumption. Consumption, again, it's something you typically you can turn on, turn off. You pay for what you use. A good way to illustrate it would be right here. Subscription typically is Office 365. If you hear someone say an Office 365 subscription, this is something you pay whether you use or not. Now, you can still add users. You may have 10 Office 365 users. You add an 11th one, you pay for the 11th one, and vice versa. Consumption is typically Azure or Amazon, or one of the real true cloud offerings when you think of cloud. In this example, I'm looking at Azure offerings, things like Azure Search, storage, site recovery, virtual machines. That's what's typically referred to in the consumption model. You may have also heard the term tenancy, single-tenant, multi-tenant. In a single tenant, one system hosts one particular cloud instance. You own your copy of the software, you have your own database, there's no data intermingled. In the multi-tenant, though, you can see on the left, multiple customers' data coexist in the same infrastructure and the same instance of software. Now, it's logically secured and logically separated, but it's on the same physical hardware. And we can illustrate it this way. For single tenancy, that may be one house with multiple family members in the house, but no other families have access to the property. So it's one house with only that family living there. In a multi-tenancy instance, that might be something like an apartment building. Each tenant has access only to their part of the building, but some resources and services are shared. Things like the initial access to the apartment building, utilities, water, trash collection, gas, those are all shared services. But nonetheless, although they share some resources, the actual residents still have their own individual apartments. So that's one way to think of it. You've certainly heard of scalability in cloud. It's one of the most powerful selling points of cloud. But we can't always, when we consider it, we can't always say that any application or any service can scale up or scale vertically and scale out or scale horizontally. Typically, platform as a service scales out and infrastructure as a service scales up. The vertical scale, scaling up, means adding resources to existing nodes. Moving a unit to a larger machine. We can say you make the box bigger. You make it the same thing much larger, or smaller if you're scaling down. That's vertical scale. Scale up, scale down. Then there's horizontal scale, scaling out or scaling in. That's typically adding additional nodes, splitting workloads across multiple computing units. If vertical scale is making a single box bigger, Horizontal scale would be basically making more boxes. Now, scaling up always provides an increase in performance. You scale up by increasing RAM speed, disk speed, CPU clock speed, and so forth. But it requires application support to scale out. You can scale up a SQL database, for instance. Any SQL database you can scale up. You can add more resources to the machine it's running on, but you can't scale it out. You can't add multiple instances of a SQL database unless the database and application support it. There are certain ways, such as sharding, to split large databases between multiple servers, but remember, horizontal scale always requires application support. You can always scale up, but you can't always scale out. Just to illustrate what we just discussed, scaling vertically, you see that machine there at the top. It might be a virtual machine, 2 CPUs and 4 gigabytes of RAM. You scale it up. It's still one machine, but it becomes larger. It's got 8 CPUs now, and it's got 16 gigabytes of RAM. Then we look at scaling horizontally. We've got that same machine, 2 CPU and 4 gigs of RAM, but we scale horizontally. That means adding multiple instances. So we end up with 4 instances, each with 2 CPUs and 4 gigabytes of RAM, as opposed to scaling vertically to one machine with 8 CPUs and 16 gigabytes of RAM. Again, just an example, but something to just visualize what the differences are. There is a caution when it comes to scale. Scale is by far one of the largest selling points of cloud. The ability to provision the resources needed, pay as you go, as opposed to the older mentality of purchase a server, have that server running in a data center somewhere. You may never need the full capacity, but if you ever do, you're still capped at that capacity. You can't grow beyond it without adding additional resources, upgrading, replacing, and so forth. But in cloud, it's often easy to click a button, and cost ramifications can be huge. We look at the example of the Azure basic A0 machine. It's a very basic machine. It's 1 core, less than a gigabyte of RAM, 20 gig hard drive, a maximum of 500 IOPS. It's an oversubscribed model, meaning that there's multi-tenancy, and it's only $13 a month. Now this would be perfect for a monitoring server, which requires very little compute, very little resources. It just requires a few processes to run. This is perfect. But with a few clicks of a button, you can have a standard GS5, which is, as you can see, a much larger machine, 32 cores, 450 gigabytes of RAM, terabytes of hard drive space, 80,000 IOPS. It's a dedicated machine, and that is roughly, at the time of writing this, around 16,000 a month. This would be used for large database processing. And then we also have, on the far right, I added the Azure Custom. Really, for much larger clients, there's no limitation to what you need and what can be provided. All of the large cloud providers, Amazon, Azure, they all have millions, literally millions of servers running in their data centers. And any one of them would be more than happy, certainly, to provision a custom application. Some big data requirement, there's certainly enough resources to go around and to be able to help any customer take advantage of them. Well, I want to thank you for watching this. Hopefully it's been informative. We try to keep it to under 30 minutes. I would advise you or encourage you to please visit us. We provide full cloud consulting. Whether it's just a review of your current cloud practices, we can review security, app dev, migrations, storage. We can look at your current costs. We provide a full cloud solution. Our logo is leveraging cloud for business success. So again, I'd like to thank you for watching. Hopefully it was informative. Hopefully you learned something. Please leave feedback. Feel free to reach out to us. Contact information is in the description of this video. And please visit us at www.7speedsolutions.com. Again, thank you very much for your time.